Okay, so I'm going to do all the odds, and then you're going to go through and do all the evens, okay? So you can do this. After watching the video, you can get these done. All right, I believe in you. You can do it. So here's how you simplify expressions with rational exponents. Rewrite all radicals in exponential form. So that's the first thing you're going to do. Write them as exponents. Use the exponent rules to simplify the expression. We learned that in concept number 1, exponent rules. Write your answer in a radical and simplest form. Rationalize if needed. You don't need to worry about rationalizing or simplest form. You just need to rewrite it as a radical. Okay? So here we go. Start with number 19. If I have two bases that are the same and they're raised to the exponents and they're being multiplied, I have to add those exponents, which we know that from concept number 1. So 1/3 plus 4/3 is 5/3. Okay, but I need to rewrite this as a radical, which means what number is going to go right here? 3, and 5 goes on the inside. And that's it. That's all you got to do. Okay? Number 21. Since I'm dividing things with the same base, I have to subtract my exponents. Okay? Since we're subtracting fractions, we need to have like denominators. This has a denominator of 2. This has a denominator of 4. I need to make this have a denominator of 4, which means I need to multiply top and bottom by 2 to get 4. So this is now 10 over 4 minus 7 over 4. Okay, if this is confusing, we need to go back to 5th grade because this is 5th grade math, okay? Combining fractions. This is not high school math stuff. This is stuff you should already know how to do. Okay, so 10 over 4 minus 7 over 4 gives me 3 over 4. All right, we need to rewrite it as a radical. So which number goes in the index? 4. And then 3 goes on the inside. And that's it. Okay? Let's do the next one. 32 to the 1/2 to the 1/2. Exponent rules tell me I need to multiply those two exponents together. 1/2 times 1/2 is 1/4. But I need to write it as a radical. So 32 goes on the inside and 4 goes on the outside. And that's it. Okay? 100 to the negative 1/2. This tells me I'm going to have 1 over 100 to the 1/2. But I need to write this as a radical. 1 over. If this is a 2, does it really need to go there? No, it doesn't. I'm going to keep going because I know what the square root of 100 is. It's 10. So my whole answer for this one is 1 over 10. Okay, moving right along. Negative exponent tells me I need to flip it over. This number is still negative though. Okay, this negative exponent has no effect on this negative. All it does is flip it over. Okay, I still need to rewrite it as a radical. The 3 goes in the index. I'm also going to simplify this one because I know the cubed root of 216. I know what number times itself 3 times gives me 216, and that's 6. So that's what this number means right here, is what number times itself this many times gives me this number, and it's negative 6. Okay. This one, before I multiply these two together, I need to write them in exponential form. So since this has no exponent on the inside, it's 1. So this is v to the 1 over 3 times 1, 2. If there's no number here, it's 2, v 1 over 2. I need to add these two exponents together. But since they're fractions, I need a common denominator. My common denominator between 3 and 2 is 6. So times 2, times 2, times 3, times 3. This is now 2 over 6 plus 3 over 6. 2 6 plus 3 6 is 5/6. rewrite this as a radical. What number goes on the outside? 6. And then b to the 5th on the inside. Okay, so that's it for that one. We only have 2 more examples left to do. Okay, so if you're ever given something like this, you still need to rewrite it as an exponent. So if there's no exponent, it's 1, right? So on the top we can write 1, 4 to the 1, over, this is 1 over 3. Okay. Like bases, I subtract exponents. Okay. I need to find a common denominator. So times 3, so this is now 4 to the 3 over 3 minus 1 over 3. 3/3 minus 1/3 is 2/3. Okay. I need to rewrite it as a radical. So what number goes here? 3. 4 squared. I can keep going because I know what 4 squared is. 4 squared is 16. And that's it. Okay. And this last one, number 33. X to the 10 over 4, because it's 10 over 4. All I need to do is simplify this. 10 over 4 reduces down to 5 over 2, and that cannot be simplified anymore. So now I can rewrite it as a radical. And since this is 2, I don't need to put it there. It's just x to the 5th on the inside. Okay? I will give you a break. You don't need to do number 34. You can cross out number 34. So when you're doing the rest of these, I want you to do the rest of them except for this one. Okay? So that's it for concept number 2. Since I did all of these with you, you can do all of these. They're all the same. They're just different numbers. Okay? Refer back to your exponent rules in section number 1 because that will help you out a lot. And refer back to this front page for how to rewrite rational exponents as a radical. Okay? So you guys can do this. I know you can. I believe in you. Try your hardest. You'll have a short quiz on Friday when I come back over this stuff. If you need to talk to me anytime between then, you can see me on Thursday since I won't be here on Wednesday. See me in the morning, see me after school. I won't be available Friday morning because I have staff meeting. Maybe I will be. I don't know. It all depends. I have no idea when I'll be in my room. So anyway, what I'm saying is if you need help on these, come see me, okay? Or go ask another math teacher. All right? You have plenty of resources. You have the internet, you have a book. The books are in the back of my classroom. Okay, you can watch the video again. Lots of resources. Okay? So I want you to get all of these ones done. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 questions. That's all you need to do, okay, before our test on Friday. All right, you guys can do it. I believe in you. Good luck.